Okay, now I will explain about Fibonacci relation and application. Okay, so what is exactly the Fibonacci sequence? The Fibonacci sequence is a set of integers that starts with a 0, followed by a 1, then by another 1, and then by a series of steadily increasing numbers. The sequence follows the rule that each number is equal to the sum of the preceding two numbers. Okay, for more clear understanding, let me show you how the Fibonacci numbers is formed. So as you can see here, the Fibonacci number starts from 0 and then by 1 and then by another 1. So we can sum out the previous two numbers, which is 0 plus 1 equals to 1, 1 plus 1 equals to 2, and 1 plus 2 equals to 3, and so on. So the sequence can theoretically continue to infinity. And then we can also present the Fibonacci numbers by using Fibonacci triangle. We can get the same result. Then how about solving Fibonacci relation? Okay, so to solve Fibonacci relation, each number in the sequence is considered a term, which is presented by the expression fn. So by means that for the first term is f1, for the second term is f2. Okay, so it's given the recurrence relation for this Fibonacci sequence is fn equals to fn minus 1 plus fn minus 2. So this formula applies to all integers. Okay, then we know the initial conditions f0 equals to 0 and f1 is equals to 1. So by using this recursive formula, we can find out the following f3, f4, and f5. So let me show you the solution. Okay, for the solution, okay, for f3, so you can just substitute 3 to n, and then we can solve it by using the initial conditions. And for the f4, we need to use f3, the numbers of f3, then we can use to find out f4, and for the following f5, f6. But the challenge with a recursive formula is that it always relies on knowing the previous Fibonacci numbers in order to calculate a specific number in the sequence. For example, you can't calculate f100 by using recursive formula. You need to always use the previous numbers. So if you want to find out the f100, we need to use Binet's formula, which we will not cover in this topic. Okay, so next is the Fibonacci applications. So we have here the branches of trees and the arrangement of leaves on the stem. So we can see if we count the number of branches in each spiral, we will find that they follow the Fibonacci sequence. So you can notice that each successive branch forming a larger angle than the one before it. So, and for the arrangement of leaves on the stem, we can see that the number of leaves in each spiral on the stem follows the Fibonacci sequence. This is thought to be an efficient and effective way for plants to maximize their use of available resources and adapt to their environment.
Hi guys, in this part I would like to show and explain to you guys what is a Tower of Hanoi and how to play the Tower of Hanoi. So what is the Tower of Hanoi? In the well-known Tower of Hanoi problem proposed over 100 years ago by Lucas, a player is given 3 packs and a certain number of distinct size and is required to transfer them from one pack to the another pack, alright? So the well-known recursive algorithm that accomplishes this task requires 2 to the power of n minus 1 steps and is the unique optimal algorithm for the problem. Alright, how to get the formula? Look at this, Tn, the number of moves to solve the puzzle with n disks. T1 equal 1, take 1 move to move the disk to another pack. Tn minus 1, take Tn minus 1 move to move the disk to another pack. And greater than 1, this must be more than 1. So next, Tn equal Tn minus 1 plus Tn minus 1. So look at this, Tn minus 1 for the purple and orange color for this to move from first pack to the middle packs, which is the second packs like this. And then plus 1 for the green. Green just only need 1 movement to move from first pack to the third packs. Alright, plus Tn minus 1 also for the purple and orange color to move from middle packs to the last packs, which is the third packs. Alright, so we got the Tn equal to Tn minus 1 plus 1. Alright, this is how to you find the pattern by using interactive method. So you guys can using this method. Also this just continue until this one, and then by using some of the geometric sequence, this is our formula, and r not equal 1. Alright, so r we put the sub value is a 2. So you can simplify this one, so you guys can get the Tn equal to the power of n minus 1. Alright, so next, how many moves can be obtained if there are 3 disks? So using our formula, and we change with our total disks, which is we have a 3, 1, 2, 3, and T3 equal to the power of 3 minus 1, we get the 7 movement. So the our mission is we must to move all of this from the first pack to the third packs with the same position and with the same color, right? So I will show you how to play the Tower of Hanoi. So first, we move the orange color to the last packs. We move the purple color to the middle packs. We move the orange color to the middle packs. we move the green color to the last specs, we move the orange color to the first specs, we move the purple color to the last specs, and the last one we move the orange color to the last spec. So we complete our mission. Remember, what our mission is, we must to move all of these from first spec to the last spec with the same position and same color, alright? With the just a 7 movement, alright? So in this part, you guys know what is Tower of Hanoi. You guys know how to get the formula of Tower of Hanoi, and you guys know how to play the Tower of Hanoi, right? So now you got this.
So I'm going to explain about money growing in a saving account, compound interest. So what is compound interest? It's the common type where any earned interest is added to the initial amount, leading to more interest in the next period, which causes the investment value to grow increasingly over time, unlike simple interest which grows by the same amount each time. This is why we use the recursive methods, because it is very useful for the finance problems that uses a repetitive process based on iterations. So this is the recurrence relation for compound interest. I am going to explain about what does this geometric sequence formula means. So A subscript n plus 1 is amount of a loan or investments after n plus 1 periods. A subscript n is amount of a loan or investments before interest is applied in the n period. A subscript 0 is principal or amount of the loan or investment at time 0. R is growth or compounding factor, that is R equal to I plus 1, and you have to know that I have to be equal to R over 100, R is interest rate per period, and N is number of interest-bearing periods. So here's an example. Write the recurrence relation for a loan of 45,000 ringgit is invested at 6.3% per annum compounding yearly. So the first question, what is the investment worth at the end of 4 years? The second question, how much interest was earned in the third year of the investment? So what is the solutions? Let's see the solution for the first question. So first step, you have to write the formula. Second step, you have to state all the variables and not that interest rate as a decimal. So you will get your relation. And the last step is substitute into the formula. So for the first step, you have to calculate it by equal to 1.063 multiplied with the starting amount of the first year. For the second year, same concept, 1.063 multiplied with the previous term, which is the previous year, which is the first year. Same goes to the third year and the fourth year. So the fourth year is equal to 1.063 multiplied with the previous year, which is the third year. So you will get the answer for the first questions. Now let's see the solution for the second questions. So third year starts at the end of the second year and finishes at the end of the third year, meaning that we need to find how much is the interest was gained in between of the end of the second year and the third year. So thus third year is A subscript 3 minus A subscript 2, and you will get the solution. So in conclusion, we have the recurrence rule that we can now stimulate and study the increase in investment over time. Unlike simple interest, compound interest, loans or investments frequently accrue interest during periods shorter than a year. So we must consider when constructing a general recurrence relation as we have done just now.
Next is application of recurrence relation. For the application, I choose merge sorts as our example for today. First, what is merge sorts? Merge sorts is sorting algorithm that works by dividing an array into a smaller subarray, sorting each subarray, and then merging the sorted subarray back together to form the final sorted array. Next is how merge sorts works. When we have an array with the size of n that contain an unordered number, the entire array will be divided into two halves, and we have two subarrays with the size of n over 2, and we apply merge sorts on this subarray until each half are being sorted, and after each half has done the sorting, it will be merged the sorted half back together, and this process is repeated until the entire array are sorted and merged back together with the correct order. The last part is merge sorts analysis. Let's denote that Tn is the time to sort an array with the size of n. Since the entire array is divided into two halves, Tn is equal to Tn over 2 plus Tn over 2 plus when we must plus with the size of the array. Hence, for the first equation, we get Tn is equal to 2Tn over 2 plus n. From the first equation, we can find the second equation by find the Tn over 2 first. And we've got Tn over 2 plus 2Tn over 4 plus n over 2. And we substitute this value inside our first equation, and we got Tn is equal to 4Tn over 4 plus 2n. And this is our second equation. Next step is we repeat the same step to find the third equation. But this time we use Tn over 4 since Tn over 4 is inside our second equation. And we got Tn over 4 is equal to 2Tn over 8 plus n over 4. And for the third equation, we got Tn is equal to 8Tn over 8 plus 3n. For the next step is we can predict the general formula by using an iterative method. And we got Tn is equal to 2 to the power of k, Tn over 2 to the power of k plus with Kn. And here we assume, next we assume that T1 is equal to 1, hence n over 2 to the power of k must equal to 1. And here we must find the value of k, and we got k is equal to log to n. For the last step is we can substitute the value of k inside our general formula. And here we got Tn is equal to n T1 plus n log to n. Since T1 is equal to 1, and we got Tn is equal to n plus n log to n. And this is our general formula. We can use this formula to find how many times to sort an array with the size of n.
Assalamualaikum and hi. So today I will explain about application of recurrent relation number 2. The other application of recurrent relation is network marketing. What is network marketing? Network marketing, or also known as multi-level marketing, MLM, is one of the business activities that are very popular among young people nowadays. And let's look at the process of the network marketing. Firstly, an individual will sell product or services directly to consumer, and then an individual earn income not only through their own services or product sale, but also recruit new workers into the network and earn commission from them. And this process will continue by the new worker and so on. To have clear understanding, I've provided one example question here. So how to solve it? Let me show you. Based on the question, we can assume that n as the number of workers, an as the profit of the n worker, an minus 1 as the profit of the n men that earned the profit from the previous man, an minus 2 is the profit of the n men that earned the profit from the previous to previous man, and note that n must be greater than 2, which means the worker in this business must be more than 2. Based on the question, we can write the formula like this one, which is an is equal to an minus 1 plus an minus 2. And for your information, that is the linear homogeneous formula. Based on the question, let's assign A as the profit of man A and A2 as the profit of man B. And we will get A1 is equal to 400,000 and A2 is equal to 200,000, which is half of the A1. And then 2% of A profit means 2 over 100 times with the previous to previous man, it will get here, and 35 over 100 times with the previous man, and we will get like this. From the previous formula, it is C1 and this is C2, and try to substitute it into the characteristic equation, and it will be like this. And find the root by using polynomial, and we will get R1 is equal to 2 over 5 and R2 is equal to negative 1 over 20. After that, by using general solution, we must substitute this root into this general solution, and we will get the formula like this. And then the problem here is we don't know the value of A1 and A2. But note that what we get before this, AN is equal to 400,000 and A2 is equal to 200,000. So we can assign AN is equal to A1, and it should be like this one, and AN is equal to A2. And also it should be like this one. And then try to solve these two equations by using Zeeman equation method. And you will get A1 is equal to 11,000,000,000 over 9, and A2 is equal to 16,000,000,000 over 9. After that, substitute the value of A1 and A2 before in the general solution. Finally, we can obtain the general solution is like this. However, we must remember that the question requires us to find the profit of the 10 men. This means n is equal to 10. Try to substitute the value of n here into this formula, and it should be like this, where the n now changes to 10. And using your calculator to calculate it, and finally you will get A10 is equal to 128.159. Hence, the total profit of the 10 men is 128.159. That's all from me. Thank you for watching this video and see you next time.